if you've missed the intro, hi everyone, I'm Mackenzie. I'm a security advocate and a developer advocate here at GitGuardian. And in this talk, on this track, we're going to be talking about taming secret sprawl. And we're going to be focusing a little bit on remediation, but remediation at scale to be able to prevent new leaks. Now, I'm going to talk about why remediation is so hard. But we'll get into just a little bit of light coverage. If you're very familiar with the topic, don't worry, we're not going to spend too much time on the basics. But just quickly, what am I talking about when I talk about secrets? So secrets are digital authentication credentials, and typically these take the form as API keys or credential pairs or security certificates. But there's a really key distinction with how I use the word secrets and how you might think of a password, for example. Now, a password is still a secret, but when we're talking about it in software development, we're talking about it as secrets that are used programmatically. This is a big distinction. It means that it's machine-to-machine communication typically. So you have an application that needs to connect to a database or a third-party service. That's not you putting in that secret to connect. That's your application, made to be used programmatically. Why is that such an important distinction? It's because this is the reason why secrets typically end up inside places they shouldn't, because they injected into source code typically. So why do secrets leak in code? This is I have a bit of a silly example here, but if we think about our secrets, where do they want to be? So we want to keep them in a vault or a secrets manager, but they often end up inside the code. Now, why is that? Well, I want to give you a scenario here. It's on my screen. One of the most common places that we see secrets is buried in our history. So in this example, we've got a Git branch. So we're probably all familiar with Git, version control. And in this case, a developer has been told, hey, I want you to work on a feature branch and I want you to build out this feature. So what they've done is they've hard-coded in a secret just to get it quickly working, right? They know that they're not going to leave it in there for the final version, but they just want to get things quickly. They just want to get connected to the API, to the server, to the database, and make sure everything's working fine. Later on, they remove it. Later on, they use an environment variable or however they're meant to deal with this. Once that goes to code review from the feature branch back to the main branch, that secret, maybe 100 commits in the history, completely buried. And no reviewer has the time to go back 100 commits to have a look at all the mistakes you made to get to this point. That's what history is. But that secret's still there. It's still in the history. So this is why we often find secrets inside our source control that no one really knows about. But they get there in other ways too. Auto-generated files and logs. If you do a debug log, it will often print out your environment. Your environment may contain environment variables, which are typically secrets. So if that log gets captured into your Git repositories because you've done git add all, then that's going to be in your version control history, and that's going to be really hard to get out, just like in the first example. What will save you from this sometimes is a .gitignore file, but we see so many repositories that don't have this. It's a simple file that say, hey, ignore any log files, ignore the environment variable file, which was the #1 file that contains secrets that we saw. So this is something that will really save you in the long run. We also see, one of my favorite is the secrets.txt file. We do see a lot of these, and typically the scenario that we see these is that they've probably got some secrets management in place with some parameters around how to access that. And the developer's gone, oh, this is so hard. I don't want to deal with the security team issuing me secrets. I'm just going to save them in my secrets.txt. And then git add all ends up in your repository. But even still, they're going to be on your local machine. They can be in template files. So if you create a Django template, they've recently changed this a little bit, so it has example in the secret, but it would have typically created a secret for that. And unless you remove that and handle it properly, if you version control that, it's going to be in your source code. And then the other one that we see is that we just see a lot of secrets purposely being put into Git repositories. You're hidden behind the idea that this is private. I need authentication, so why can't I put it in there? And I'll show you the answer to that question of why this is such a problem, particularly in private repositories. So we have our secrets in a vault or a secrets manager, like Doppler, who was just on the panel here. So what's the typical path that happens? Okay, developer needs a secret, requests it through Vault, gets the secret from to the developer. That ends up in our source code repositories through any of the various means that we have. But you're saying this source code repository is private. Why is this a problem if it's private? And the reason it's a private is because source code, particularly through Git, will sprawl everywhere. It'll end up on your networks. That secret will end up in your messaging systems. It'll end up in your wikis. It's on all your developers' machines now that are working on that project because they've cloned it in. It's in your drives and your backups, and it's in your documentation. Now, me as an adversary, I'm looking to target any one of these systems because I know I'm going to be able to find secrets to escalate my privileges. So this is kind of really why it can be such a big problem and why it sprawls. And it doesn't matter that the source code repository in this case is private. Now, we've already showed you some results from the state of secret sprawl in the keynote, where we talked about how we scanned all the public commits on GitHub, over 1 billion commits, and found over 10 million secrets. These are public secrets. So I don't want to talk too much more about the public side of things. I want to go into private repositories, and then I want to go into remediation of that. So I want to take it away from that public sphere and go into it. But before I do that, just a couple of quick things that you may be interested in. What are typically the secrets that we find in Git repositories? And they're probably different to what you think. And they're pretty sensitive. So for example, 25% give access to databases or data storage, and 20%, so remember we found 10 million, so 2 million were cloud provider keys. Now we validate cloud provider keys, so 2 million valid cloud provider keys. That's a pretty scary number that's out there in public. But as I said, private repositories are much worse. Private repositories are really where the treasure lies. And this is why we've really seen a shift in adversaries recently in targeting the code repositories of companies. Now, they can do this through a number of different ways. One of the ways that they do it is actually through supply chain attacks. So they're targeting things. So we saw this with Circle CI and also CodeCov, that they're targeting these supply chains to get access into the private repositories of companies. Why? Because they're treasure troves. They contain lots and lots of that secret. So I want to give you some examples of just how much secrets are in there and why that happens. So the first thing I want to talk about is how private repositories are really not that private. Last year, we saw a huge amount of companies that had their private source code leaked, or as I like to call it, involuntarily open sourced. So, the Lapsus group at the start of last year caused absolute havoc, getting into Microsoft, getting into Samsung, getting into NVIDIA, and leaking out their source code publicly. And it caused a huge amount of problem. So how did these bad actors actually get access to these source codes? Well, less sophisticated than you might actually think. So firstly, Lapsus were mostly just paying employees to get access to it. They were either buying credentials off the dark web. This is how they got into Uber later on in the year. Or they were paying employees of certain companies to just give them access to the network or to their private repositories. So it's not this really sophisticated attacks that they were doing. It's not necessary. Source code is sprawled everywhere. You need minimal access to be able to get a foothold into it. So really, we've seen huge amounts of these source code leaks. Now, I want to hone in on one, and that's Twitch. So Twitch in October 2021 had all of their source code leaked out. And this is going to be important when I talk about something, particularly in remediation. So let's take a look at what we saw in Twitch. What actually happened? There was a misconfiguration on their Git server that allowed remote connection. It allowed an adversary to remotely access all their Git repositories and basically clone them. And they then shared that on a torrent. We got access to that source code and we scanned it. And what we actually found was that there was over 6,000 secrets that were inside Twitch's source code. Now, bear in mind that there was 6,000 repositories. This was a huge code base. There was 3 million documents. So you might be thinking, wow, that's so bad. 6,000 secrets? You'd be wrong. This is actually really good. in what we typically see in an organization, Twitch has done really well. But we still found 194 AWS credentials in their source code. We still found 69 Twilio keys, and we still found 14 GitHub OAuth keys. So what do these all do? These give me as an attacker ability to persist my attack and elevate my privileges into different areas. So whilst Twitch has obviously done fairly well in maintaining secrets, they've still got 6,000 secrets exposed in their repositories. And this is just to show really the state that we're actually in when it comes to sensitive information in our source code. So why is it that we have so much sensitive information? Surely we can find them and remediate them. So I want to take you on a bit of a journey now that probably may sound typical for anyone that's working in AppSec as to why this is so hard. So on average, if we take a typical company that has around about 400 developers. Now, this is kind of a smaller company, but one that's kind of typical. We have a lot of customers around this size. We have a lot of customers a lot bigger, but 400 is kind of like a typical company that we'll see. Now, the industry standard is about one AppSec engineer per 100 developers. That's just the reality of the situation. So 400 developers equals around about 4 AppSec engineers. So now let's say that this organization has said, hey, I've listened to Mackenzie's talk at CodeSecDays. I want to know how many secrets that we actually have in our repositories. And what you will typically find is there'll be about 13,000 secrets of a company this size inside private code repositories. So this is a pretty big number, much higher than what we just saw in Twitch. So this is pretty typical. So you've discovered 13,000 secrets. Now, about 1,000 of these will be unique because once a secret enters in your repository, it will clone itself. But how do you know that the secret's repeated? How do you know that these 1,000 secrets, you've got 13,000 secrets, that basically means you've got 13,000 incidents that you have to investigate. Doesn't matter that they're repeated because at this point, you don't have that information. So what does that work out for? It works out to about 3,250 secrets per AppSec engineer. So an AppSec engineer has to investigate, communicate with the developers, try and find out what this secret does, how critical is it. Then they need to rotate that secret, redeploy a new one. They need to do all of that without creating any downtime. And then perhaps they need to kind of clean up that history and make sure that secret's out. They have to do that 3,250 times. That is totally unmanageable. So this is part of the reason why a lot of people just kind of ignore this problem because, hey, once you know you have 13,000 secrets in your source code, you kind of have to do something about it. But if you don't know, like no harm, no foul, right? So head in the sand approach can be typical here. So this is why the problem of remediation is so hard. And it continues to get hard. So first of all, we have to catch them all right? We don't want any false positives. That's really difficult because detection is a challenge. Secrets are probabilistic, so they typically are high entropy strings, but not all high entropy strings are secrets. So we have to catch them all. That's a very complex challenge. They're everywhere. They're in your source code. They're in your build pipelines. They're in your Slack conversations, your Jira tickets, everywhere. We discussed that at the start. The depth keeps growing. So you've got 13,000 secrets now, but next week you might have more. So that's exhausting. And here we go again, right? Rinse and repeat. We're rotating, we're replacing, and then that secret's going to get back into your source code, and you're going to have to deal with it all again. So it's really a hard challenge. But what's the hardest part about this? Now, a lot of people kind of think that secrets detection, the detection part, is the biggest challenge. And it is a challenge. Getting high quality secrets detection with low false positives is big of a challenge. But it's not the biggest challenge. Remediation is absolutely the biggest challenge because this is where we have the smallest amount of teams. And this is where I kind of want to bring you up to speed on the GitGuardian product and what we've been doing, because I want to introduce you to the methodology and mindset that we use to be able to do this. Because in this company that I just discussed, yes, you have 400 developers and 4 AppSec engineers. But if you actively implement DevSecOps, then you have 400 developers that can potentially help you remediate this problem. You have 400 people, your team's expanded massively, and you could actually get on top of it. Now, you need tools to be able to trust these developers and ensure that it happens, but this is the methodology that GitGuardian approaches in trying to bring everyone together to actually get on top of this, because it doesn't matter how many tools you introduce into it. If you have 4 AppSec engineers dealing with this on their own, this is going to be an absolute nightmare. So I have these pretty slides here with our product that look really nice, but I think what I'm going to do is I'm going to go rogue. I hope that's okay if I go rogue for you for a minute, because I want to get off the slideshows and I just want to show you what the product actually looks like and how we can actually help solve this problem. Because this isn't just about the product, it's also about the mindset shift of how we deal with it. So you'll notice on my screen here, I'm just in my perimeter. I'm in a fake organization, so if you see any secrets here, then don't worry, they're fake. But we have all these repositories connected. And what we're going to do is, let's say we've just rolled out and we've done a historical scan. And now all of a sudden, I have here secrets, 2,774 secrets. So this is the point where a lot of people are confronted with. They get to this point and they're going, oh my gosh, almost let a swear word slip. Oh my gosh, how do we actually deal with that? So there's a couple of ways we can deal with it, but I want to get onto some of the magic too. So the first one that we can do is we actually do validity checks. So we can see, hey, are these secrets valid? Hey, that's a good place to start. Let's get into valid secrets, or perhaps ones that we can't see are valid. And then we can also say, hey, how many of these secrets are actually exposed publicly? And so now we see the types of secrets that we have that are valid and exposed publicly. And we can add lots of other filters as well that relate to that. But then you'll see here that we have a lot of secrets that have the severity as high. And if we just get valid ones, we'll see we have a few secrets that are just critical. So this might lead you to the question, how does this critical severity actually get assigned? And this is one of the really cool and important parts about it, is that we can automatically assign this based on your own rules. So I'm just going into the secrets detection area, and we have severity rules. It lets us know how much coverage we have. So in this example organization, 81% of the secrets that we found have been able to be assigned a severity. And we can set rules for this. So valid database credentials, obviously very critical. Valid secrets related to high sensitive detectors, obviously very critical. So this actually helps us immediately help you on your remediation process, because now instead of organizing by all these different things, I can just say, hey, show me all the critical secrets that we have. Let's start there. Now, let's go into one of these secrets, and we have here the secret that we have. We're able to see it. I want to stress again that this is fake. So anyone trying to take a picture of their screen to do some crypto mining later is going to be disappointed. But we have lots of issues here that we can see. But as I said there, is that we've still only got 4 AppSec engineers. All right, we've helped you prioritize the incident, but you still have to get through all of them. So how do we actually go about reducing this burden and this load? And this is where it starts getting really cool, is that we can actually start getting the developer involved. So incident sharing is something very cool, where we can share this. And what that means is that we know who the developer is that's committed this in nearly all cases. So what happens is a developer from the organization leaks a credential. We can immediately start getting information from them. So we can send them a survey, which will look like this once it loads up, which will ask them a few questions about what the secret actually is. And then they can answer that here. You can already see that the remarks have been made here. And this is displayed in the dashboard, that we can see the remarks here. Now, what's really interesting about this point is that the developers can actually remediate themselves. Let's say that they know what the secret does. They have access to the AWS account that issued it, so they're going to mark it as invalid. Well, now, what's really cool is that you'll see that we know that this secret is valid, and we'll keep checking to see if it's valid. So once this secret is marked as invalid, and if we can see that it's been removed from the timeline, then the developer can mark this as resolved. Now, the incident will still be there, so you can investigate it, but you can actually start getting through the incidents themselves. So now you can involve the developers into the security process. You can trust them to remediate secrets because we can verify that the secret has been remediated to the standard that you would like. So we can also check to see if it's in the Git history still, for example. So if you want to get it removed, so that we have these processes of checks. So now that you can actually trust your developers to go about this remediation process. Now, I could spend all day on the GitGuardian platform, but this talk, I just wanted to really talk and focus on remediation and how the platform really helps in that critical part about it. So I'll skip through the slide. This is the workflow that we had that I just showed you about getting the developers involved to help them remediate the incidents. And the great thing about GitGuardian is that through single sign-on, SSO, then you can also actually give them access to the dashboard where they can see all their incidents, but only their incidents. And they can actually be a part of that. So it's really about taking a proactive approach in DevSecOps. This is really thrown out there all the time, DevSecOps, as a buzzword. But the actual reality, what does DevSecOps look like in reality? It looks like developers playing an active role in security on their responsibility, and that can be verified by the correct people. So that's what it looks like, and that's how we start to get control of these programs. So it allows you to have that centralized control, but also have dedicated roles and team leaders that can also look at that. So that role-based, that RBAC. So you have your centralized AppSec team. They have visibility over everything. And then you have your smaller perimeters that help you navigate between your teams and give different permissions so that different people can see the incidents that affect them, that they can control. And this goes all the way down from the AppSec team to the developers so that we can really accelerate that trust. So I want to talk about one other thing now. I've got about 5 minutes left, but there's going to be just enough time to talk about prevention. Because, all right, we've talked about the remediation process and how the developers can get part of it. But what we haven't done is actually stop the bleeding. So yes, better education, getting them involved will help them be more aware, but you're still going to have secrets coming into that. So I wanted to talk about how we can actually get them more involved to be empowered to stop leaking secrets. And we've got some great tools that can really help you to do this. So I don't know if anyone here has tried to get developers to use security tools. Like sometimes it works fantastic, and sometimes they just don't want to leave their environments. So if you are going to give them security tools, it's my recommendation that they fit in to their workflow, right? Let the tools fit into what they're regularly used to so that they can actually use it. And GitGuardian has done a great job at integrating secrets detection into the into the CLIs, the command line interfaces that developers are used to working. So right now, what we've just talked about is this. We don't have guardrails on. We have our remote environment, and you'll see the little GitGuardian L on the screen here, right here. This is connected to our Git server, and this is where we're running secrets detection. But we haven't got anything happening on the developer's machine. We don't have any secrets detection actively happening on the developer's team. But if we start putting secrets detection in other areas, then we can drastically reduce the work of that AppSec team because we can reduce the secrets that are entering into there. So again, I want to go a little bit rogue. I apologize to my team for doing this. But if you're used to some developer environments, this may look familiar to you. Oops. Trying to make it a bit bigger. So what I have here is just a regular environment, and I have a .env file. So if you notice in the polls, .env file was the #1 file that leaked secrets. So I'm sticking with that trend. And we have here an AWS access key. So now let's say in the example that I've done git add all to this. So I've accidentally captured this environment variable file into it. And I'm going about my workflow, and I try and commit this into it. So if we run a commit here, what's going to happen is we're going to be blocked. And this is because GitGuardian is running on the CLI and it's detected an AWS key. It's detected that it's valid. Again, it's a dummy credential. It's a honey token. You're going to be disappointed if you want to do crypto mining later. But it'll also give the developer instructions on how to remediate it. What's the key about this? Hey, we're still in the developer's workflow. We haven't left. But what we have done is actively prevent this secret from entering into the remote repository. So this is all about enabling developers in that DevSecOps so that we can actually start to get on top of this really unattainable problem. This problem seems so big at the start, but it can be solved using the correct collaboration and really embracing DevSecOps.